Let's talk now about factoring trinomials using the product sum and the AC methods. Factoring is not a single skill. It's not a single formula or a single strategy that can be used for any polynomial. Factoring depends on the kind of polynomial you're looking at. Here we're going to be looking at factoring trinomials. Now remember, trinomials are polynomials that have three terms. So here we're going to be looking at two different kinds of trinomials. They're both going to be quadratic trinomials, meaning their biggest power is 2. They're going to be second degree trinomials. So here we're going to be looking at factoring second degree trinomials. The difference is going to be whether or not they have a lead coefficient. So there's going to be two different possibilities. Either you have x squared plus some number x plus some number. Really, it should be plus or minus because they can be positive or negative. Plus or minus some number, x plus or minus some number. If that's the case, notice there's no coefficient in front of your x squared. This is like saying 1x squared. In this case, you're going to be using the product sum method, which we'll go over here first. However, if you do have a number in front, something like ax squared, so 2, 3, 4, 5, plus or minus some number x plus or minus some other number, then we're going to be using what's called the AC method. All right, so let's just jump right in. Our first example is going to be of the first variety. We're going to have something like x squared plus 9x plus 20. The way to factor something like this requires us to observe how we get expressions like this in the first place. Okay? Let's say I was going to multiply together something like x plus 2 times x plus 3. Okay? Well, the way we multiply these is x times x gives us x squared. X times 2, or let's see, x times 3 first, so that's going to be 3x. And then 2 times x, that's going to be 2x. And then finally, 2 times 3 is your 6 on the end. When you combine your like terms, 3x plus 2x will give us 5x. Just like this. Notice that those two numbers, the 2 and the 3 right here, if you add them together, it gives you this number in the middle. Because, of course, that's how we got that number in the middle. 3x plus 2x. 3x plus 2x. Those same two numbers, when you multiply them, give you this number on the end. Because, of course, that's how we get that number. 2 times 3 gives us 6. Right? So when we multiply things out, adding these two numbers gives us this term in the middle. Multiplying these two numbers gives us this term on the end. So if we wanted to go backwards, if we had a quadratic trinomial, a second degree trinomial, then we should be looking for two numbers that multiply to give you that last number and that add up to give you this number. Or in other words, we want something whose product is that number and whose sum is the number in the middle, hence the product sum method. So that's what we want. We want to find two numbers that when multiplied together give you the number on the end. Those same two numbers, when added together, should give you this number in the middle. Not the variable, just the number. All right, well, that's going to be 5 times 4. 5 times 4 is 20. Meanwhile, 5 plus 4 is 9. So once we have those two numbers, notice over here, the 2 and the 3 that we have tell us that our binomials here are x plus 2 and x plus 3. Likewise over here, these two numbers are telling us that this will factor into two binomials, x plus 5 because of that 5, and x plus 4 because of that 4. The order doesn't matter. If you had done the 4 first and then the 5, you had x plus 4 and x plus 5, that would be just as good. So here, this one's a perfectly good answer. And if you won't switch them and you end up with x plus 4 times x plus 5 instead, if they're the other way around, that's fine too. These are exactly the same. Because, of course, when you multiply, the order of multiplication doesn't matter. 2 times 3 is the same as 3 times 2. And this times that is the same as that times this. So the order doesn't matter. All right, let's see that again. let's say we're going to factor x squared minus 2x minus 35. All right, same idea. We want to find two numbers that when multiplied together give us this number on the end. Now notice that's a minus 35. That minus is part of that term. So we want two numbers that multiply to give us negative 35. Those same two numbers should add up to give us this term, this coefficient in the middle. Again, that includes the negative. All right, so two numbers that multiply. Notice, if they're multiplying to give you a negative, that means one of them's got to be negative, one of them's got to be positive. Okay, so one's got to be negative, one's got to be positive. All right, so what numbers, positive and negative, multiply to give me negative 35? Well, I could do negative 5 times 7, or I could do negative 7 times 5. They both work, so which is the correct one? Well, remember, not only do they have to multiply to negative 35, they also have to add up to negative 2. So if I have negative 5 times 7, okay, that is going to give me a product of negative 35. But if I have negative 5 plus 7, adding those together gives me a positive 2. And that's not what I want. Because in order to add two numbers to get a negative, I would need the number with the biggest absolute value to be negative. So here, these are the right numbers, but they have the wrong sign. Here, I want that the other way around. I want that to be negative 7 and positive 5. That is also going to give me negative 35 as a product. But now, since the negative is on the number with the greater absolute value, then that means the sign of the answer will also be negative. So these are the two numbers that I want, which means that in the end, my result has to be x. Now that's a negative, so we're going to say minus 7 times x, and that's a positive, so that's x plus 5. Again, the order doesn't matter. If you write the x plus 5 first and then the x minus 7, that's okay. As long as you have a negative 7 and a positive 5, a negative 7 and a positive 5, it doesn't actually matter which order you're in. So if you have this one, that's correct. Or if you write this one, that is also correct. Now, you might be asking, what if I can't come up with those two numbers? All right, well, a little disclaimer. Unfortunately, this method doesn't work for every second degree trinomial. Right now, we're dealing with ones where it will work. All right? However, there are going to be some where this method just doesn't work, in which case we need something more advanced. And that's not what we're talking about right now. There are other techniques beyond just these types of factoring that will work on trinomials. So right now we're dealing with only the ones that it will work for. Okay, but then you might ask, well, even if it does work, what if I just can't find the numbers? What if it works? What if this is the problem that I can do with the product sum method, but I just can't figure out what the two numbers are? Well, there's a strategy to help you find those numbers in a reasonable amount of time. Huh? So let's consider x squared plus 8x minus 48. All right, and again, I'm going to factor this. All right, that's what all of these are. We're going to factor. All right, now, if you can already think of the two numbers, that's great. I want to find two numbers that multiply to give me negative 48 and add up to give me positive 8. Okay, now if you can already think of what those two numbers are, great. But let's say for a second that you don't. Let's say for a second that for whatever reason you're stuck on this one. Okay, so how should I approach this? What you want to do is you want to start with the product. There are lots of numbers that add up to give you positive 8, but there's not as many combinations of integers that multiply to give you negative 48. There's lots of integers that add up to 8, more than have a product of negative 48. So we're going to start with this. Okay, so let's give this a try. What do I need to multiply to give me negative 48? Well, I know I need one of these to be a negative and the other one to be a positive. So first let's worry about that sign, right? A negative and a positive will multiply to give me a negative. Okay, but now what are the two numbers? Well, now that the negative is taken care of, what numbers can I multiply to get 48? Well, there's 1 times 48. That's always going to be a choice. 1 times the number itself will always get you that number. All right, so notice right here, Yeah, if I have 1 and 48, if it's either negative 1 and positive 48 or the other way around, yeah, that'll multiply to give me negative 48. But if I have negative 1 plus 48 or negative 48 plus 1, that's not going to give me 8. Okay, so that doesn't work. Okay, so what's next? What I want to do next is I want to count up. 1 times 48 gave me 48. Let me go to the next digit. Let's try 2. Can I divide 48 by 2? Well, sure, I get 24. Okay, well, let's try that. Negative 2 times 24, or negative 24 times 2, I know that's going to give me negative 48. But what about when I add? Well, if I have negative 2 plus 24, that's 22. And if I switch them, I get negative 22. So here, these don't work either. Okay, let me take another step. Let's try 3. Can I divide 48 by 3? Yes, I can. I get 16. 16 times 3 is 48. All right, so again, these two numbers here are going to get me 48. Well, what about when I add them? Well, let's see. If I have negative 3 plus 16, that's 13. Or if I switch them, that's negative 13. That doesn't work either. Notice that I'm getting to skip a whole bunch of numbers over here. Yeah, right here I'm saying 1, 2, 3. But over here I went from 48 to 24 to 16. Notice that I never had to worry about trying 25, 26, 30, 32, 35, 38, any of those. By doing this, it allows you to test fewer numbers, because now I know for a fact that, hey, 1 times this, 2 times this, 3 times this, there are no numbers in between here, and there are no integers in between 1, 2, and 3, which means there are no integers for me to try between 16, 24, and 48. So let's keep going. Let's try 4. Okay, so 4 times 12 will give me 48. Notice I'm starting from the outside, working in. That way I don't skip any. All right, so I know that'll multiply to give me negative 48. All right. Let's try here. If I have negative 4 plus 12, oh yeah, that works. That's it. That's the right one. Negative 4 plus 12. Keep the sign of the bigger number. That's going to give me 8. Meanwhile, negative 4 times 12, that'll give me negative 48. So yes, that's the correct one. I have a negative 4 and a positive 12. So this strategy will help you organize your thoughts, and it will help you get to an answer in a reasonable amount of time. If you just start randomly guessing and saying, okay, 7 plus 1 is 8. Okay, that doesn't work. Okay, 9 plus negative 1. Okay, but no, that doesn't work. 16 and 3. No, that doesn't work. If you do it that way, in a disorganized fashion, you're going to have to try a lot more than this. All right. So now we have our two numbers, and that gives us x minus 4, and that's a positive 12. So this will give us x plus 12. And there we go. So give this a try. If you can just come up with the two numbers off the top of your head because you are good with your times tables, that's great. If not, using this will help you organize your thoughts. In any event, go ahead and give this a try. You're going to factor x squared minus 9x minus 90. All right. Go ahead and pause the video and give this a try. You shouldn't need me to confirm the answer at the end, though, because remember, this is a factorization that we're looking for. By the time you're done, your answer, you should be able to multiply it back out and get your answer, get your original polynomial. You should be able to say that's x squared plus 12x minus 4x minus 48. And here, combining your like terms will give you x squared. 12 minus 4 will give me 8x and negative 48. So we will come back and confirm this once you're done. However, you shouldn't need me to say anything other than to say good job, right? Because here, once you're done, you will be able to check it yourself by multiplying it back out. So give it a try. Go ahead and pause the video, and once you're done, go ahead and unpause, and we'll go through it together. All right, so let's give this a try here. We want two numbers that multiply together to give me negative 90. Those same two numbers should add together to give me negative 9. All right. If you come up with the numbers already, great. If not, then you can organize it this way. Let me go ahead and, for a moment, let me pretend that well, that I haven't done all these problems ahead of time, right? So let me go ahead and pretend that I don't know what my numbers are, and let me go through and search for them. All right, I'm looking for a product that gives me negative 90. Okay, well, that means I know I need one negative and one positive. All right. Numbers that multiply to give me 90 are 1 and 90. But if I take negative 1 and 90, or negative 90 and 1, that definitely doesn't add up to negative 9. All right, so let's keep going. Let's try 2. Can I divide 90 by 2? Sure, I get 45. Okay. Yeah, but that doesn't work here. Negative 2 plus 45, that's 43. And if I flip them, that's negative 43. Either way, that doesn't work. Okay, let's go on to the next one. Let's try 3. Yeah, I can divide 90 by 3. I'll get 30. Oh yeah, but that doesn't work here either. Because negative 3 plus 30 is 27. Or if I flip them, I get negative 27. So that doesn't work either. Can I divide that by 4? No, I can't actually. If I divide 90 by 4, I don't get a whole number. I don't get an integer. Okay, so let's try 5 then. Notice I skipped 4 because that one we're not going to get any whole numbers. Here we're looking with just whole numbers. Okay, so let's try 5. Yeah, we can divide 90 by 5. That's 18. That's pretty close, but that doesn't quite work because here if I have negative 5 and 18, that's 13. Or if I switch them, that'll be negative 13. So that's not quite right, but that's pretty close. So I think maybe the next one should work. Can I divide 90 by 6? Yes, I would get 15. Okay. So let's try this here. Negative 6 plus 15. That would be positive 9. Okay, so then I just need to switch them. I need the sign of the bigger number to be the negative one. So here that's going to be negative 15 and positive 6. That way negative 15 times 6 will give me negative 90. And negative 15 plus 6, keep the sign of that number with a greater absolute value, that's going to be a negative 9. So my two numbers are going to be x minus 15, and here that's going to give me x plus 6. Or again, if you wrote x plus 6 first and then x minus 15, either of these is the correct answer. Anything different than either of these would be incorrect. Okay? So now, these are all examples of the product sum method. We're looking for two numbers whose product is this and whose sum is this. Product and sum. Product and sum. Product and sum. But all of these depend on the trinomial not having a lead coefficient other than 1. This is just 1x squared in every instance. What happens when we do have a number besides 1? Well, then we're going to use the next method called the AC method. All right, so let's go and see how that works. We're going to factor 10x squared plus 29x plus 21. Okay. With the number in front of the x squared, we know the product sum method won't work with this the way it currently is. What we want to do here is we're going to use what's called the AC method. The reason it's called the AC method is, if you look at the way this is written, ax squared plus bx plus c, a represents the number that's out in front of the x squared. C represents the number on the end, the constant. This is called the AC method because the very first step of the problem, the very first step of this procedure, is to take the a and the c and multiply them together. A times c. Right? So that's the first step. You're going to take the first number here, that's a 10. You're going to take not the variable, just the number. You're going to take the constant, which is 21. If that was a negative, that negative would be included as part of our number. So include the sign. And you're going to multiply those together. Okay. What do you get when you multiply those? 21 times 10, that's 210. So what I want to do now is, and this is going to sound familiar, I want to find two numbers that multiply to give me something and add up to give me something else. But now, instead of saying I want to find two numbers that multiply to give me to this last number, what I want is I want two numbers that multiply to give me this product. In other words, I want two numbers that multiply to give me 210. Those same two numbers, whatever they are, that multiply to give me 210, should also add up to give me this middle number. this 29. So the product of these two, find two numbers that multiply to give me that 120 and add up to give me this 29. Okay? Now, if you're rather good with your times tables, that may be automatic to you. That may be something you can come up with off the top of your head. Otherwise, you're going to use this strategy again to find out the two numbers that work. Start from the ends. In this case, you would start with 1 and 2, 10. And if that worked, great. If not, you would keep going. Eventually, you're going to find that the numbers that we need here are 15 and 14. If you add 15 plus 14, you get 29. If you multiply 15 and 14, you get 210. All right, now, with the product sum method, once you find those two numbers, you're done, right? Well, with the AC method, it takes a little bit more than that. Here's what we're going to do. Take your first term and just write it down. That's 10x squared. Take your last term and also just write it down. Now, you're going to leave a little space in here because something's going to happen in the middle. So this plus 21, we're just going to bring it down, plus 21. But now, what's going to happen is this middle term, instead of just bringing it down as 29x, we're going to bring it down using these two numbers. Meaning, instead of plus 29x, I'm going to write it as plus 15x plus 14x. Whatever two numbers you found right here, that's the two numbers here. Instead of writing it as 29x, we're going to write it in two parts. First plus 15x, and then plus 14x. If you won't switch them, that's fine. As long as you use these two numbers, 15 and 14, that's okay. All right, so now what? We've gone from having a trinomial to having a polynomial that has 4 terms. Well, when you have a polynomial with 4 terms, you can factor by grouping. So let's do that. When we factor by grouping, we look at just the first 2 terms on their own. And say, all right, looking at those 2 terms, what's the greatest common factor there? Oh, well, the greatest common factor from 10x squared plus 15x, that's going to be a 5x. So now, if I have 5x, that's being divided into each of these, 10x squared divided by 5x will give me 2x. All right, 10 divided by 5 is 2. X squared divided by x is just x. And I have a plus right here. 15x divided by 5x. Well, the x's divide away completely. So that just leaves you 15 over 5, which is 3. Once you look at the first two, look at the next two, and do the same thing. Repeat the process. The greatest common factor between 14x and 21 is the number 7. They can both be divided by the number 7. That's the biggest number that divides into both of those. So let's divide by them. If we take 14x divided by 7, that leaves you 2x. If you take 21 and divide it by 7, that leaves you just a positive 3. But now look at the term in the orange. Look at the term in the green. The term in the orange and the term in the green, those two terms have a common factor, 2x plus 3. And when you have a common factor, you factor that out. But then, since we're factoring out 2x plus 3, what's left? Well, that's our remaining factor. If you take this term and factor out 2x plus 3, that leaves you just your 5x. If you look at this term and factor out your 2x plus 3, that just leaves you your plus 7. And this is your factorization. You can always check this. You can always check any factorization problem if you just multiply it back out. If you take 2x plus 3 times 5x plus 7, multiply, that's 10x squared. Multiply, that's 14x. Multiply, that's 15x. And multiply makes 21. Combine these like terms, 14x plus 15x, and that'll give you 29x, which is exactly what we started with, 10x squared plus 29x plus 21. So that confirms that this is the correct factorization. So here all we're doing is checking it. All right, let's see that again. Another example. Let's have you try 8x squared plus 14x minus 15. We're going to do this together. Here we're going to factor out this trinomial. It's got a number in the front, so we can't use the product sum method. We're going to use the AC method. All right, the first step is to take this first number, the 8, not the variables, just the constant, just the coefficient, and multiply that coefficient by the constant out here. Now notice that's including the negative. So if you multiply those together, let's see, what's that? 8 times negative 15, that's negative 120. So we want to find two numbers that multiply to give us 120. Those same two numbers should add up to give you this number in the middle, which is 14. Okay. We want to multiply two numbers that multiply to negative 120, so we know one's got to be positive and one's got to be negative. Like that. And if you're good with your times tables, you may be able to come up with this a little faster. If not, again, we do have this strategy here. You can write out, starting from the end, you can say, okay, 1 times 120, does that work? No, okay. How about 2 times 60, does that work? No, okay. And you keep going until you find the right result. Okay? So let's go ahead and give that a try here. Two numbers that multiply to give me 120. I already got the negative taken care of, so let's just use the numbers. 1 times 120. Okay, well, that multiplies to this, but if I take negative 1 plus 120, that's 119. If I flip them, that's negative 119. Either way, that's not 14. Okay, so that doesn't work. Let's try. What about 2 times 60? That's the next number on the list. All right, 2 times 60. Oh, that doesn't work either, because negative 2 plus 60 is 58. And flip them, that's negative 58. So that doesn't work either. I can divide this by 3, though. Let's try 3. That's 3 and 40. 3 times 40 is 120. But here, this doesn't add up right. Negative 3 plus 40, that's 37. And if you flip them, that's negative 37. That doesn't work either. Can I divide this by 4? Yes, I can divide it by 4. 4 times 30. Let's see. Negative 4 plus 30 is 26. And if I flip them, that's negative 26. So that doesn't work either. Can I divide this number by 5? Yes, I can say 5 times 24. Okay, so 5 times 24, that's fine. But if we say negative 5 and a positive 24, that's 19. And if I flip them, where the 24 is negative and the 5 is positive, that would be negative 19, which is pretty close, but that's not right either. But I think maybe the next one should work. Let's see, that's going to be, if I divide this by 6, that's going to be 20. So let's try 6 and 20. If I do negative 6 and positive 20, yeah, that's it. That works. So negative 6 times 20, that's negative 120. We know that for sure. But when we check this one, look, negative 6 and positive 20. Oh, keep the sign of the bigger number. So 20 minus 6 is 14. So there we go. Those are the two numbers, negative 6 and positive 20. So now we're going to go ahead and split this apart. This first term is just going to come on down. So this will be 8x squared. Now your middle term, you're going to split it using those two numbers. It doesn't matter what order you write it in. So you can write the plus 20 first and then the minus 6, or the minus 6 first and then the plus 20. Makes no difference. Here I'm going to maintain the same order I have. So I'm going to write that as minus 6x plus 20x, which does come together to give you 14x. And then you have your minus 15, which you just bring it down. So this splits, and the other two just come down. So now we factor by grouping. These two terms have a common factor of 2x. If you divide each of these by 2x, that's going to give you 4x, and that gives you a minus 3. Looking at the other two terms, 20x minus 15, both of those can be divided by the number 5. So plus 5 times, if I divide this by 5, you get 4x. And if you divide this by 5, you get minus 3. Well, look at the term in the red and the term in the green, or the orange and green. They have something in common. they have a common factor of 4x minus 3. Since that's a common factor, we can factor that out. When you remove this factor, when you divide out by this factor, if you take 2x times 4x minus 3, and you divide out 4x minus 3, you're just left with 2x. And same in the green, if you take 5 times 4x minus 3 and divide by the 4x minus 3, that leaves you just the plus 5. And that is the factorization. And if ever you're not sure, you can always multiply it back out, and that'll confirm that this is correct. So give it a try. Using the AC method, factor out 28x squared plus 29x plus 6. Go ahead and pause the video. This might take a few minutes. And once you're done, go ahead and unpause the video and we can go through it together. All right, so let's give this a try. In the AC method, the first step is to multiply together A times C. Okay, so 6 times 28, that's 168. So we want to find two numbers that multiply together to give us 168. Those same two numbers, whatever they are, need to add together to give us 29. Okay. All right, well, here everything is positive, so we don't need any negatives. Everything's going to be positive. Two numbers that multiply to give us 168 and add up to give us 29. We can do 21 and 8. And again, if you have a hard time coming up with those two numbers off the top of your head, use this strategy and you'll get these numbers. The AC method is not a fast technique. It works very well for expressions with very large and complicated numbers. However, it can take a bit of time. If this took you 5, 10, even 15 minutes, that's perfectly normal. All right, so we have our two numbers. So we can write this as 28x squared. Instead of 29x, we're going to split this as 21x plus 8x. Again, doesn't matter what order. If you wrote 8x first and then 21x, that'll be fine. You'll still get the same answer at the end. And then your 6 just comes on down. So now, looking at just these two terms in the front, I note that both of them can be divided by 7, and they both have an x in common. So 7x is a common factor. If I divide this by 7, I get 4. If I divide x squared by x, I get x plus 21 divided by 7 is 3. And then the x divides the x, and that just goes away, right? X divided by x is 1. So really this is 3 times 1, which really we just leave as 3. Looking at the remaining two terms, they have a simple common factor. They can both be divided by the number 2. So plus 2 times. And if I divide these by 2, I get 4x and 3. Just like that. So now if I look at the terms in the orange, if I look at the term in the orange and the term in the green, I notice that this term and that term have a common factor. The common factor being 4x plus 3 right here. So whenever you have a common factor, you factor that out. That becomes your first factor. Your second factor is what happens when you divide these terms by the common factor. If I divide away the 4x plus 3, I'm just left with a 7x here. And if I divide away the 4x plus 3, I'm just left with a plus 2 right here. So 7x plus 2. And that is our factorization. Again, if you were in doubt, you could have multiplied this back out. 4x plus 3 times 7x plus 2. 7 times 4 is 28. X times x gives us x squared. 4x times 2 would give us 8x. 3 times 7x would be 21x. And then 3 times 2 would give us 6. And if you combine these two like terms, you get 28x squared. 21x plus 8x is 29x plus that 6, which is exactly what we started with. So here this does confirm that that is the correct factorization. And that's it. Should you have any questions, comments, or problems, please make a note of those and reach out to me. And I hope everyone has a nice day.